Lesson 3, the temperature conversions one. So let's take a quick look at some of the stuff here. I know there's a bunch of it that you know from the ed puzzle, so I'm not going to spend too much time going over some of the obvious stuff. So first of all, you can see the guy, Mr. Palermo, he gives us this equation here, the K equals degrees Celsius plus 273, like that. And so if you're solving for Kelvin, which we are here, you just simply take whatever it is you have in degrees Celsius, and then that would be a negative 83 degrees plus 273, okay? And then that's all you have to do to solve this one. If we were to have, I'll show you some other examples of how we keep the same, thing, the same equation, but use it in a different way. Because that's how he does it. He tries to give you like one thing to remember, and then you just solve for the other part of it. It's pretty easy. How many Celsius degrees separate the freezing and boiling of water? Of course, that's 100. What are these two temperatures? For degrees Celsius, that would be 0 and 100 for freezing and boiling. Lowest possible temperature is a negative 273, and we know that because of this conversion factor between Kelvin and Celsius. How many Kelvin separate freezing point? Again, what he's trying to get at is that Kelvin and Celsius are equal in magnitude. So 1 degree Celsius equals 1 Kelvin, but they start at different places. So if I increase the temperature 5 degrees Celsius, I've also increased it 5 Kelvin. That's what he's trying to get you to understand. How many Kelvin separate freezing and boiling, and what are these two temperatures? That would be 273 and 373, like that. So let's keep going here. Here is where we can actually practice a little bit. So here we got our Kelvin equals degrees Celsius plus 273, like this. And then if I'm starting with Kelvin, that would be 383 Kelvin, like this, equals, and then we don't know what degrees Celsius is, so we got to move the 273 to the other side, and we do that by subtracting, and this of course equals 0, and 273 this way, like this, would then give us 110 degrees Celsius. My board's getting a little funky, so that's 110 degrees Celsius, like that. And that's how we convert from one to the other. So notice that for the next one, and this is the last one I'm going to do for you as an example, is degrees Celsius plus 273, like this. And it says that we have 80 degrees Celsius, so we just literally put this in at 80 degrees and we add like that. That makes it very simple. As far as this gives us 353 Kelvin, and that's what our answer is here. There we go. 353 Kelvin. Okay, you can finish this out. It's not too difficult to do, just using the same equation over and over again. It says, why do you think the sum calculation of formulas are required to convert Celsius to Kelvin? Here's one of the major reasons why. Table S, melting point and boiling point are in Kelvin. Okay, so you're going to have to be able to go from Celsius to Kelvin to use table S. So table S in your reference table, what temperature does sulfur melt at? So we take a look here at sulfur. Sulfur is the one that's highlighted. It melts at 383. I go back, I say 383 Kelvin. So you know that you're in Kelvin. What temperature does sulfur freeze at? Now here's the key. Okay, melting point is equal to freezing point. Melting and freezing are the same point. Okay, so 383 is also the freezing point. So we continue on here, and it says, did I miss something? Nope. So for number 10, what's the freezing point of silver? You go to the next one. Silver is here. It's there. You can fill that in. Oops. Mercury, look that up on table S again. You can see that here, table S. Down here for green, for mercury, has the boiling point. So, and temperature of gallium is a solid, liquid, or gas, and explain. So let's take a quick look at this. So gallium, oops, let's go backwards one. So gallium down here is right here. Now this is the melting point. That's what this is, melting point. This is the boiling point. Now here's how you read this. If you have a temperature that is less than the melting point, then you have a solid. If you have a temperature that's higher than the boiling point, then you have a gas. If you have something that's in between the melting point and the boiling point, then what you have is a liquid. So this says gallium at 300 Kelvin. So what's gallium at 300 Kelvin? 303 means it from 303 to 2477 would be a liquid. So here what we have is gallium on this side, which means that gallium in this case is a solid, because anything above 303 would be a liquid or a gas. Okay? So solid is what we have. And we have our last one then that explains how to do bromine. I'm writing down the same thing here for you. It says, is bromine a solid, liquid, or gas at 22 degrees Celsius? Where's bromine at? Bromine's down at the bottom here. Okay. So that means, now here's the problem. This is 22 degrees Celsius. So what I do is for Kelvin, I put 22 plus 273, and that gives me 295 Kelvin. Now what is 295 Kelvin for bromine? Bromine's down here at 266 and 332. 295 is right in the middle, which makes that a liquid. So I go back up and I can say this is going to be a liquid because it's in between. Okay, good. Hope you guys had some success with that. Good luck.